In today's tutorial, we're going to be creating this digital clock that actually works in Blender. In a previous tutorial, we created this analog clock. However, we didn't give any control over what the start time would be. So you'd actually have to move to the given frame to actually start the animation. However, since Blender doesn't allow an infinite number of frames, that becomes quite tedious for times that don't work within the frame range. So to fix that, in this video, we're going to learn how you can set your own time using a few simple math nodes before starting off with the entire clock animation. After creating the digital clock, we'll go ahead and visit how we can add the same nodes into our previous video, and after that we'll have a little bonus content where I'll try to create a Python script to take the current system time and use that in geometry nodes. So with that, let's begin how to create this digital clock in Blender using only geometry nodes. In our default scene, we'll bring our cursor to the junction of these two windows, click and drag to create a new window, and we'll change this to the geometry node editor. Then we'll press this plus button to create a new geometry node tree, after which we'll zoom in, select the group input, and tap X to delete it. Now we need to know how many seconds has passed both since the animation has started and from the initial time that we give. To get the number of seconds, we can search for a scene time node, and this directly gives us the seconds as an output. Now to actually set the initial time, we can search for three value nodes, one for the hour, one for the minute, and one for the second. So let's just take this value node, press Shift D twice, and then we'll set the names for each of these as well. So let's select this, go to the node tab, and just change the label to hours. This one we can call minutes, and finally the last one we can call seconds. And ideally we have to convert all three of these into seconds and add them to the seconds that have passed since the animation started, and then decode those again into the new hours, minutes, and seconds. So the first thing is converting everything to seconds. Remember, hours consist of 3600 seconds. That means 1 hour consists of 60 minutes. Each minute is 60 seconds. We get 60 into 60, that's 3600 seconds per hour. So we can search for a math node, and we have to change the type from add to multiply and multiply it by a value of 3600. And this is the number of seconds in the hours. However, right now the value that we're taking in is a float value, which means somebody can give 1.1 hours and things like that, which we don't really want because we want it to be like, okay, either 1 or 2 or 3 whole numbers or integers. So to fix that, we'll just search for a float to integer node, plug that in, and we don't want it to round up. We always want it to round down no matter what it is. So we're going to change this to floor, and that way we're always going to get a whole number for this, and we get the right number of seconds. Next, for the minutes, remember 1 minute consists of 60 seconds. So we can duplicate these two nodes by pressing Shift D, plugging this into the value over here, and instead of multiplying it by 3600, we multiply it by only 60. Finally, for the seconds, we only need to clamp it down so that nobody gives fractional seconds, and the output of these are the total number of seconds. However, we need to add all of these together, so let's shift these to the side and search for three math nodes. So let's press Shift A, search for math, and we're going to keep it on add itself. So let's add the number of seconds that have passed since the animation started to all of these values. So let's first add this one in, press Shift D, connect this up here, and connect this value here. Then again, take this, Shift D, take the resultant, and add in the last one over here. Now this is the total number of seconds that has passed. So let's just select all of these nodes, press Ctrl J to frame them, and call it total seconds, and move it to the side. Now this total seconds has to be used to calculate the number of hours, minutes, and seconds. So let's find out the number of hours that has passed initially. So let's search for a math node, and remember, this is giving us the number of seconds that are coming out, and to find the number of hours that has passed, we have to divide it by 60 minutes and 60 seconds. So that means we need to divide it by a total of 60 into 60, which is 3600, to get the number of hours that has passed. Let's plug this in, change this from add to divide, and divide it by a value of 3600. Now this is giving us the number of hours that has passed, but it'll be a float value, which means it'll be maybe 2 point something something something. We don't want that. So let's search for a float to integer node and change the type from round to floor, and that way we get the right value for the number of hours that has passed. Remember, you don't have to use a float to integer. You could always use a math node and change the type from add to floor, and you would get the exact same result. However, we'll be using the float to string node itself. Next up, this is currently an integer, but to actually display the value, we need to convert it to a string. So I'll search for a value to string node and plug this value into the value. Now this is going to be the string. We have to convert it to a curve or a mesh before we plug it into the group output, but for now we'll just leave it as is. Next, to get the number of minutes, we can take this, press Shift D, and plug it down. And remember, we need the number of minutes that are remaining after we've taken out the hours. For that, we have to actually use modulus so that we get the remainder after we do division. So let's press Shift A, search for a math node, change this type from add to modulus or modulo, and we need to divide the value by 3600 so that we're removing the hours and having what's left. So let's divide it by 3600 and plug this value into the divide. Now we don't need to divide it by 3600 this time. We need to divide it only by 60 to get the number of minutes. Remember, this output is giving us the remainder number of seconds, and those remainder seconds are becoming minutes using this divide node. And again, we're using the floor value and converting it to a string. This is going to give us the number of minutes. Now let's go ahead and duplicate this again to do the number of seconds. For the seconds, we need to do another modulo operation. Let's move this to the side, press Shift D and plug it in here. And this time, instead of 3600, we have to do 60 because we've removed the hours using this modulo. And in this modulo, we're removing the number of minutes. Then we don't require this divide node, but we can keep it and just leave it at a value of 1. And this is going to be the number of seconds from here. However, there's an issue, which is in a digital clock, the hours can generally be 1, 2, 3, and so on till 11 and 12. But for the minutes, we generally don't use just 1, 2, 3. We use 0, 1, 0, 2, 0, 3. Same thing goes for the second. It should be 0, 1, 0, 2, 0, 3. But if you were to convert these to curves and actually plug them into the output, we would get only a single digit when it's less than 10. To make sure that we get 2 digits when it's less than 10 as well, we'll go ahead and press Shift A and search for a switch node that we can switch between either having this value directly or 0 plus this value. Now, we're not switching between geometry, we're switching between strings. So let's change this to string, and now we can switch between two different strings based on some comparison. So if this value over here is lesser than 10, then we want to use a 0 plus this string. So to get 0 plus this string, we can search for a string node and just type in the number or digit 0, and we have to add this string to whatever string comes out over here. So let's press Shift A and search for a join string node and plug this string in here and this string in here. But remember, if we do it like this, the order matters. So we'll get 1 0 instead of 0 1. So we have to make sure that this is plugged in on top and this string comes in at the bottom. So if you actually take a look at it, this string is coming into the bottom and the 0 over here is coming into the top. So that's absolutely right. So we can plug this into the true statement and plug this directly into the false statement. So we have to see if something is true, then we use this. So what should be true? This value should be less than 10. Since this is a string, we can use this value to do all of the calculations. So let's search for a compare node, and this is an integer. So we'll change this from float to integer, and we'll check if this integer is less than the number 10, then the 0 should be added. So we can plug this result into the switch, and now this is going to be 0, 1, 0, 2, 0, 3 till 0, 9, and then it'll be 10, 11, 12, and so on and so forth. We can add in this same set of nodes to the seconds as well. So let's take this and this, press Shift D and plug it down here. For this string, we can add that into this join strings, take this one, plug it in here, and take this into the false, and take this integer and plug it into A. Now we have the seconds, we have the minutes, and we have the hours. So we have to actually convert them into a single string. So let's press Shift A and search for a join strings node and just join all three of them. Remember, the hour hand has to go on top, followed by the minute hand, followed by the number of seconds. Now this delimiter is what separates these particular digits, and we'll actually use that. So let's search for a strings to curves node and just plug this into the string and plug this curve instance into the output so that we can actually see it. And right now it's at 0, 0, 0. Let's give it some arbitrary hour, minutes, and something. So let's say it is 2 o'clock. The number of minutes that has passed is 45 and 20 seconds. Now this 20 seconds is not getting added in because we haven't connected this add value to the original modulo over here. Now we have the 25 seconds as well. However, you can't tell at all what this number is. So to actually differentiate between the hours, the minutes, and the seconds, we generally add in a colon. And to give that colon, we can simply plug in the colon over here, and that way there will be a colon between each of these. Now I think this is a bit too close. So I'm just going to add in a space before the colon and a space after the colon, and that way we get this nice spread out number, which looks great in my opinion. However, because this is a digital clock, I wanted to have some sort of digital font. So in this strings to curves node, I'm going to change this from left to center and top baseline to middle, after which I'll choose some digital 7-segment display from my fonts folder. So I'm using Bleak Segments. It's a free font that's present on the internet. In case you want to use the same font, you can download Bleak Segments from different websites. Next, right now, this is just a curve. If you actually switch off overlays, you see nothing. So we need to convert this to a real mesh. To do that, we're going to press Shift A and search for a fill curves node, and that way we get a mesh. And we don't want to fill it with triangles, we'll fill it with n-gons itself because we're not going to be doing much operations on it. The only operations that we want is to give it some thickness, for which we'll search for an extrude mesh node, and we'll change the offset scale down to something like 0.05, and we'll switch off individual just to make things a little faster. After which you see the bottom is completely hollow. We need to fill that up. So to fill it, we'll search for a join geometry node, and we can simply connect this in here. However, this might cause shading errors if you ever need it. So it's better practice to flip the normals by using a flip faces node and plugging that in right here. Now we have the digits, which are going to actually change based on the frame number, and that's good enough for a digital clock. However, we need to give it some sort of clock nature. So let's go ahead and add in those borders now. Before that, let's just organize the nodes by pressing Ctrl J and and calling this time formatting. Now to give it the sides, let's go ahead and add in a box, delete an insetted face from it, give it some thickness and create the border. Let's press Shift A, search for a join geometry so that we can have both the text as well as the new border that we're going to add. For the border, I'll search for a grid node and just plug this into the geometry. Next, we have to actually size the grid node accordingly. So I'll give it a size on the X of something like 5.5 and maybe a size on the Y of 2. However, this doesn't seem to be perfectly centered. So I'll search for a set position node and I'll just move it up on the y-axis by 0.1 and now it seems to be perfectly centered. Next, I want to actually inset it and delete the inset face. So the trick to inset in geometry nodes, as we've seen multiple times, is searching for an extrude mesh node, switching off individual and reducing the scale to 0, after which we search for a scale elements node and take this top selection and plug it into the selection and just scale this down by a little bit, let's say 0.8, and you'll see what happens if we do this with non-square grids. So we'll actually change this in a while, but let's see what happens with this first. After which we want to delete the insetted face. So I'll search for a delete geometry, choose the same top selection for the selection, and we don't want to delete all of them. We want to delete only the faces, and we can change this to face so that the faces remain. Now you see, since we actually scaled it up non-uniformly, we don't get a uniform inset. So to fix that, instead of scaling it uniformly, we'll scale it on a single axis only. For now, we'll choose the x-axis and scale it down by, let's say, 0.8 itself. After which we'll take the scale elements node and duplicate it and plug it in again. This time, instead of the x-axis, we'll go for the y-axis by typing 1 on the y-axis and 0 on the x-axis, and then we'll choose the same top selection for the selection, after which we can play around with the scale until we feel like it is fairly square. So I think this gives it a nice square border, but I think I'm going to reduce the scale or the border thickness as well. So I'll change this to maybe 8.9 and this one up as well till I feel like it's fairly equal. For now, I'm just going to eyeball this. Now, just like last time, this is a thin 2D plane. We need to give it some thickness. So I'll search for an extrude node, press Shift A, search for an extrude mesh, plug that in, switch off individual and scale it down till it's fairly a decent size. So I think 0.1 is good enough. And remember, right now the base of this and the base of this is at the exact same position. So if you want to simply add in a plane over here, it's best that you move it down by a little bit using the set position before you do that. However, we'll be doing something slightly different, so it's all right for now. Next up, I want to give this some sort of roundness, for which I'll search for a subdivision surface modifier and just plug that in. Now, if I increase the levels, it becomes nice and smooth, but I don't want it to be this oval in shape. I'll just increase the edge crease by a little bit, let's say maybe 0.25, and I think that shape is good enough for what I want to do. Next, I'll search for a set shade smooth node and plug that in after the subdivision surface. So that gives me this particular side, but the bottom is still hollow. So to cover that up, I'm actually going to take this entire thing and just make a duplicate at the bottom. So I'll press Shift A, search for another join geometry and search for another transform geometry as well. Now I'm going to take this geometry and just rotate it about the y-axis by 180 or the x-axis by 180. Both of them are going to give the same result, and then plug this into the join geometry. Now it moved to the side because we actually shifted it up by 0.1 units on the y-axis. So instead of rotating it on the x, we'll rotate it about the y itself, and that way we should get an exact copy, which gives it a really nice border, and I'm happy with that. So we can take these nodes, press Ctrl J and call this clock border. Next, we need a glass plate on top and some sort of a back face at the bottom. So I'll press Shift A, search for a grid node, give it the same values as this grid over here, or you could simply take this node itself and use it, but I'll duplicate it over here in case I want to make a few changes later on. So this I'm going to go with 5.5 and a y value of 2, and then I'm going to plug this into the joint geometry. Then I have to subdivide the surface by searching for a subdivision surface node and changing the levels to 3, and I'll increase the edge crease as well. And you see it's a bit too low. That's because we shifted these up by 0.1. So I'll search for a set position and I'll move it up on the y-axis. And instead of actually changing the size to make it fit, what I'm going to do is I'm going to reduce the edge crease down to 0 and just increase the levels to 3, and it should perfectly fit within the plane. So I'm not really too bothered about it. However, it's at the origin. We need to shift it up so that it comes above the letters. So I'm going to change the Z value until it comes just above the letters but stays within the border. So I think something like that is fine. Now let's select these, press Ctrl J and call this glass. For the back plane, I'm going to press Shift D so that all of these are copied, plug this into the joint geometry, change the name to BackFace, and I'll change the Z location on the set position to a negative value until it comes to the bottom, and that seems good enough for my settings. With that, we should be done with the geometry node section, and we can start off with the actual materials. So for setting the materials, I'll go ahead and set my defaults and assign materials here. For my rendered defaults, I'll switch on bloom and screen space reflections. Under screen space reflections, I'm going to switch on refraction so that we can have the glass be see-through. Then I'll go to the material properties. Remember, we have 4 different objects here. We have the actual text, we have the border, we have the glass, and the back face. So I give 4 material slots by adding this plus button 3 more times, changing the main material to text. Then I'll select the second material slot, add in a new material, call this borders. Then the third one, I'll add in a new material and call it glass, and the last one I'll call BackFace. Now we have to assign these materials, so I'll press Shift A, search for a set material node, and then I'll press Shift D and duplicate it onto all 4 of these lines. And now I'm gonna go ahead and give them the materials. So this one is our text, this one is coming from our borders, this one is coming from our glass, and this one is coming from our BackFace. So that seems like everything's done with the geometry node section. Now we can actually start texturing it. So let's go to our shader editor by pressing this button and changing our viewport to rendered so that we can see the changes. And the first thing that I want to do is play with the glass so that we can actually see the text underneath it. So for the glass, we'll go ahead and select the principled BSDF and tap X to delete it, and then simply search for a glass BSDF. Plug this into the surface, and we won't be able to see through it unless we go to the settings over here, change the blend mode from opaque to alpha blend, switch off show backface, and check screen space refractions. And that way we'll be able to see through it, but we'll still get the reflections from any other lights in the scene, so it's very evident that there is glass. You can always keep it just like this and it'll be really nice and crisp, but I think just for some realism, I'll add in a roughness of 0.1 or 0.2, and you can also play around with the IOR if you feel like it. So I think I'll go with the value of 1.6, and that should give quite a bit of refraction. The next thing that I want to play around with is the actual text material. So let's select the text, select the principled BSDF, and tap X to delete it. I want it to be emissive and transparent at the same time, so I'll search for a mix shader, plug the shader into the surface, and for the first shader I'll search for an emission node, and for the second shader I'm going to search for a transparent node. Then I'll plug the transparent into the second shader, and remember, to actually see any amount of transparency you're going to have to come back to the blend mode, and this time we're going to actually change it to alpha hashed, because if you keep it at alpha blend, it's just going to be invisible because it's already covered by one material that has alpha blend. Blender EV ignores any other alpha blend materials behind one material that's already alpha blend. Apart from that, I'm also going to change the shadow mode to none, and I'm going to do the same thing for my glass material as well. Change the shadow mode to none. Next, for the emission color, I'm actually going to give it this nice bluish color. You could go with anything that you want, maybe a greenish color, or I've seen most digital clocks have red color in them, but for now I'll go with this bluish color, and I'll increase the strength from 1 to something like 100, and I just really like the look of that. Next, for the borders, I'm just going to go ahead and make it nice and metallic, reduce the roughness down to 0.4, and maybe decrease the base color by a little bit, and that should be good enough. For the back face, I'm just going to make it metallic, make it completely black and completely rough. Now for the light, I'm going to increase the radius by quite a bit so that it's nice and soft, and then I can go to the world background and just reduce this all the way to black. However, the problem with reducing it to black is that if you go to any side angle and switch off overlays, all of this just becomes camouflaged with the background, so we need some amount of light to fall on it. You could always add in more lights to the back and things like that, but what I find easier is changing this from object to world, and in this world properties, add in another mix shader, plug that in after the background, and select the background, press Shift D, plug this into the shader, and then search for a light path node and plug is camera ray into the factor. Then you can take this first background and just start lighting it up, and that way you'll have some amount of light falling onto these sides, which just looks good in my opinion. Of course, make it fairly low so that it doesn't become brighter than the light and you can no longer tell the actual edges, so keep it fairly low and that should be good enough. Remember, it's always best practice to light everything up using lights, and that'll actually make these edges much better, but for now I'll just go ahead with this. And with that, you have this nice little digital clock that you can place on tables or wherever you feel like. You can always rotate it about your axes and just place it on your table or your floor or wherever you want it to be to create your perfect animations. And it also changes along with the frame time, so I think that's a really good counter. That's all there is for the digital clock. However, let's go back to the analog clock and we'll actually fix an issue that we had with that as well. So right now you see this entire node setup that we created at the beginning. If you were to use the analog clock video that we created, instead of plugging in the scene time seconds into the second hands, minute hand, and the hour hand like what we did, what we can do is use the same setup that we just created and plug this value into the second hand, hour hand, and minute hand, and that way you'll be able to set the time according to whatever value you want. However, there's one small issue that I accidentally had in the previous video. I'm not sure if any of you are actually watching this, but I actually divided it by 3600 and multiplied it by 6 itself, because over here we were multiplying it by 6. Now remember, the reason why we multiplied it by 6 over here is because 1 minute corresponded to 6 degrees, but that's not the same for hours. There are actually 12 hours in 360 degrees, so that's why we have to divide 360 by 12 and multiply it by that value. So in this case, 360 by 12 is 30 degrees, so we have to multiply it by 30 and not 6, and then you'll actually get the right animation. So in my previous video, that was a mistake and I'm correcting it in this video. Hopefully that will help people from making that mistake. Now the last section of today's video is a bonus section, which is trying to get the system time or the current real time into geometry nodes. So for that, I actually played around quite a bit and tried a lot of scripting, but I couldn't spend too much time on it, and it eventually led me to a dead end. But even that amount could be quite useful to many people, so I'll share that much with you. First off, I'll create a new Blender scene, and in this Blender scene, I'm going to go ahead and click and drag to create a new window, and this time I'm going to change it to the scripting window or the text editor. Now I'll press this plus button to create a new text document, and remember, Blender uses Python, and Python has a library called datetime which we can use. So let's actually import bpy, which is Blender Python, after which we can import datetime from datetime. So let's search from datetime, import datetime, and we'll also add in comments so that everything is readable. So this is importing the necessary modules, and once we have datetime, we can actually store the current hour, minute, and seconds into 3 different variables. So let's search for 3 variables. Let's just create them. So let's say h is going to be our hour variable, and we're going to say datetime dot now dot hour. So this is going to give us the hour from current date time. Then we can do the same thing for minute. So we say datetime dot now dot minute, and then for the seconds we say datetime dot now dot second. This is initializing the current time. Next, if we want to access this in Geometry nodes, we have to use attributes. So let's add in a new attribute. So the syntax for adding in a new attribute is bpy.data.meshes, and you have to label which object you are actually adding in this attribute to. So right now I have only one object in my scene, which is the cube. So I'll type in cube.attributes.new, and when you add in a new attribute, you have to mention a few things, which is the name of the new attribute. So I'll call this hat, which is our attribute, and you have to mention what is going to be stored in the attribute, which is integers. So I have to say int, and what the domain is, whether it's for the points, instances, spaces, or so on. So I'm going to actually use the point domain. Although I really wanted to use instance, you'd have to convert it to an instance first, and every time I just try making it instance, Blender crashes. So I'm going to leave it as is for now. But remember, because we're using points, each object has multiple points, so this has to be done multiple times, and that's also an issue. So I'm actually going to convert this to have only 1 point later on. Next, we have to do the same thing for the minutes and the seconds. So I'll select this, press Ctrl C, and press Ctrl V and Ctrl V again. This time I'm going to call this at, so it's minutes attribute and seconds attribute. Next, we have to write data into these attributes. So adding data to the attributes, it's a fairly similar syntax. So let's actually copy these, press Ctrl C, Ctrl V. Now after attributes, we have to start mentioning which attribute we want to change the data to. So we'll change this and say first hat.data, which takes the data, and then we have to set it using a function called for each underscore set. Now we want to set the value, and we want to set it to hours. But remember, this thing is not expecting just an integer. It expects a list that has the same number of digits as the number of vertices present, and it has to have keys that match accordingly, which is why it's easiest to just make sure that there's one value, and this works. Next, we want to do the same thing for minutes and seconds. So I'll select this line, press Ctrl C, enter Ctrl V, and enter Ctrl V. Now this one is for minutes, this one's for seconds, and then back here this has to be at, and this has to be at. Now when we run this, it'll take the current time and store that into an attribute over here. Let's actually press tab to go into edit mode and press M, merge at center, so that we have only one vertex or 1 point, after which we can add in a new geometry node tree to this object. So let's change this window to the geometry node editor and press this new button, press N to hide that. Now essentially we can search for an attribute node which is called named attribute, and here if we actually change this to integer, we will find hat, at, and at once we run this script. Before we run the script, let's also open a spreadsheet so that we can see the values once they come in. So let's change this to the spreadsheet, and right now you see this has only the position for 0, 0, 0. Now let's go ahead and scroll till we find the run button and run the script. The moment we run it, we get hat, which is 3 a.m, at 25 minutes, and the seconds is 52. So we should get 3:26 a.m. here. Yeah, so right now it went by 1 more second, but it's getting us the correct time, and that is now stored in the name attributes. So now we actually can get the hour attribute, which is going to be 3 a.m, and we can also get the minutes as well as the string or the seconds. So now we can actually use these values in the geometry node howsoever you please, but I haven't actually been able to use this to create a clock as of now, because these are fields and changes with different points, and to actually use them in most operations, they have to be single values and not fields in the applications that I wanted to use. But of course, now that you have this data present here, you could use it in many ways. So that's it for the bonus section, and I know this was a bit longer, but I didn't want to give this as a separate video considering that I'm not actually making anything with this, so I packaged it into this particular video. If you watched this far, congratulations and thank you so much. It really helps me and it keeps me motivated as well. If you like this video, there's tons of videos on my channel which will definitely teach you something or the other. Until the next video comes out, thank you so much for watching. Keep creating and stay creative.